Yes, structure of atom we have completed. So today I am going to start the most important chapter, that is atoms and molecules, right? Chalo. Atoms and molecules. Do you know what is the atom? What is atom and what are molecules?
Atom is the smallest particle of matter.
Yes. So here atoms are the building blocks of matter. Okay, already we discussed. Any matter is made up of a tiny particles called atoms. Yes, and of course we studied atomic structure. We are completed. In that atoms, first is J. Dalton's theory. According to that, atoms are indivisible. But here atoms are divisible. We studied this all. Yes. Now, how can you see the atom defined? So, the definition of atom is the smallest unit of matter that takes part in chemical reaction. How can you define the atom? The smallest unit of matter that takes part in chemical reactions, that is an atom. And what are molecules? What are molecules? The combination of atoms is called molecule. The combination of atoms means atoms combine to form a molecule. Is this clear to you? Right. So, see here now. So, here if you see, this is a matter already we discussed, and this matter is very big, and if I apply the force on it, so I can break it, and it can be divided into two pieces, and again that piece I break again into two pieces, again that I will take one piece, again break into two pieces. Like this if I continue, then finally a stage will come where I cannot break it. Okay? Such unbreakable particle is called atom. This was the idea of atom which had our ancients, okay, ancestors. Ancestors means what? Ancient people, okay, like 500 BC. 500 BC, BC means what? Before Christ. Now we are in 2022, and 2022 plus back 500 years back, okay, that is called 500 BC, means almost 2700 years back. So, 2700 years back, there was an idea, okay, that when you break one matter, any matter, and continuously if you continue on, then finally a stage will appear where we cannot break that particle, okay, that matter. Such smallest particle is called atom, okay. And in India, the name to that particle, that smallest particle, is given as Paramanu. What it is given as? Paramanu. Okay. So, Paramanu. Okay. So, here it is given like Paramanu. Okay. So, around 500 BC, Indian philosophers like Maharshi Kannada postulated the theory, if we go on dividing matter, we will obtain a smallest particle beyond which the further division cannot be possible. Further division cannot be possible, which is known as Paramanu. Okay, so this is a Paramanu. Okay, in India about the atom, and around the same age, means at the same time, even Greek philosophers also had an idea, such type of an idea, that any matter, if we break continuously, and finally a stage will come where we cannot break that particle or that matter, such smallest particle is called, okay, atom. So, here the meaning of atom is indivisible. Meaning of atom in the Greek language is what? Indivisible, means we cannot break it. Okay. Now, you can see around the same era, ancient Greek philosophers Democritus and Leucippus suggested that if we go on dividing the matter, a stage will come when particle obtained cannot be divided further, cannot be divided further, okay, and that particle was named as atom, okay. The meaning of atom is indivisible, means what? We cannot break that atom. That was the idea of atom during those days. Is this clear to you? Chalo, take the screenshot of this one. Right. Now, then go to the next one. So here, Anthony Lewis, okay, see name, this name is very important. So here you see Anthony Lewis, he is considered as a father of chemistry, okay, he is considered as what, who? Father of chemistry, okay. So he proposed, means he combined the two laws, okay, foundation of the establishing the, so he said, okay, laid the foundation of chemical sciences, he laid the, okay, foundation, for chemical sciences, and the two laws, okay, one is called as law of chemical, means these are laws are called laws of chemical combination. In that term, he proposed the law of conservation of mass. He proposed what? Law of conservation of mass. Do you know what is the law of conservation of mass? Yes? Do you know? What is the law of conservation of mass? Very good. So mass can neither be created nor destroyed, okay, during the chemical reaction. Always the mass remains constant, okay. So this is called the law of conservation of mass, okay. So law of conservation of mass states that, okay, mass can neither be created nor destroyed in a chemical reaction. So this is called as a law of conservation of mass, okay. So means what? We cannot create the mass, and similarly we cannot destroy the mass during the chemical reaction, okay. So during the chemical reaction or before and after the reaction, the total mass remains same, constant, okay. First, do you know what is the chemical reaction? Yes? What is the chemical reaction? Okay. Chemical reaction is nothing but a chemical change. Have you learnt already physical change and a chemical change? Yes or no? In that chemical change, okay, there is a new, okay, there is a change in the composition, new substances formed, okay, the properties of the products is different from the properties of the reactants. So such chemical change is called as a chemical reaction, okay. So chemical reaction is nothing but a chemical change. Chemical reaction is nothing but a chemical change, right? So what this states is, for example, listen carefully, for example, I'll take okay, I'll give an example. So law of conservation of mass, what it says is, the total mass of the reactants is equal to total mass of the product. Do you know what is the reactant? What are called reactants? Yes? The substances which are undergoing the reaction, or the substances which are combining something, okay. So that is called reactants. And what actually formed after the reaction, those are called as the products. Those are called what? Products. So law of conservation of mass, what it states, if we take the two substances, and if we combine, means if we make the chemical reaction between them, then we can get some new substances. We can get new substances are formed, and these new substances mass, if you check, okay, the mass remains same as the first one. For example, you see here, they have taken the silver nitrate and the sodium chloride. Okay, so here I am writing here. Okay, so here I am taking the silver chloride. Okay, silver nitrate. Sorry, silver nitrate. Okay, and sodium chloride. Alright. Okay. So silver nitrate and sodium chloride. Okay. So here what I am doing is, here you can see here in this picture, here this is a conical flask. What it is called? Conical flask. In this conical flask I am taking some silver nitrate solution. Okay, sorry, sodium chloride solution. So this is a sodium chloride solution. I am taking, this is sodium chloride solution. This is NaCl solution. Okay, and then I am taking one test tube. I am taking one test tube. In that test tube I am taking some silver nitrate solution. I am taking silver nitrate solution. So here you see this is a test tube. I am taking silver nitrate solution. This is silver nitrate. So here it is given silver nitrate solution. So this is a silver nitrate solution. Carefully I am taking. Okay. Now what I do, I will take one thread and I try to this one slowly, carefully I put inside, and then I close this conical flask. Okay. And now I measure the mass of these two. So in this test tube, what is there? Silver nitrate is there. Silver nitrate. And in this conical tube, what is conical flask? What is there? Sodium chloride solution is there. So two, yes, silver nitrate and sodium chloride solutions are there. Okay, carefully I am checking. Okay, I am measuring the mass of that one. Now if I check the mass, okay, on the electronic balance, then what I am getting here is 300.23 grams I am getting. How much mass I am getting? 300.23 grams. Okay. Now inside what are the solutions are there? Silver nitrate and sodium chloride. See here, silver nitrate and sodium chloride solutions are there. Okay. Now after taking this, what I do after taking this measurement? Okay. Now I will take the beaker. See, I am shaking that conical flask. I am shaking that conical flask. When I shake that conical flask, what happens? This in the test tube, what is there? Silver nitrate solution is there. That silver nitrate solution spill, enter into this conical flask. Okay. Now the conical flask, what is there? Sodium chloride solution is there. Now this sodium chloride and silver nitrate solution both are mixing together. Okay. When these both mix together, then I'll get what happens? A white precipitate is formed. Actually, these both are liquids. Okay, these both are solutions. But when both mixed together inside a white precipitate means what? Like a powdery substance which is insoluble substance. A white insoluble substance of silver chloride is formed. Now inside if I see, then what happens? I'll get the silver chloride, plus sodium nitrate. Sodium nitrate. Now, what are the substances I have taken? Silver nitrate. But what I got here? Silver chloride. Silver nitrate changed into silver chloride. And here sodium chloride. Sodium chloride is changed into what? Sodium nitrate. So, I got two new substances. Okay. I taken two substances and I got a new substances which are different from the first two substances. Okay. So, here two new substances are formed here. Okay. Now what I do after forming these two substances, now once again I will take this conical flask. Inside the test tube is there, that all solutions are there. This all acids I am putting inside. But now here now also if I see the mass, how much I can find here? 300.23 only I can find here. Okay. But what are the products inside? Now the products inside are silver chloride and sodium nitrate. The products inside are what? Silver chloride and sodium nitrate. But actually initially when I have taken, what are the reactants? Silver nitrate and sodium chloride. I have taken the two different reactants. Now I got the different products, new products I got. But if I check the mass of the reactants, that is before the reaction, and the mass of the products after the reaction, then the total mass in both the cases remains the same. Okay, so meaning is what? Mass can neither be created nor destroyed during the chemical reaction, or the total mass of the reactants and products remains the same before and after the reaction. This is known as law of conservation of mass. Is this clear to you? So take the screenshot of this one. Taken? Right. Okay. Now let's go to the next topic, that is called law of conservation of law of constant proportions. Okay. So is that clear? Law of conservation of mass, any doubt in that one? No. Chalo. I am going to ask one question to you. You say here, for example, I am burning 12 grams of carbon. How many grams of carbon? 12 grams of carbon I am burning. Okay, 12 grams of carbon I am burning in oxygen. Okay, certain amount of oxygen here I am burning. Okay, with oxygen. How many grams? I don't know. Okay, but you know that when carbon burns in oxygen, it forms a carbon dioxide. Do you know this one? So for example, you think I got the carbon dioxide. Whatever the carbon dioxide I am getting, I am collecting in one jar, and if I measure the amount of carbon dioxide, I got 44 grams of carbon dioxide. You think I got how much carbon dioxide? 44 grams of carbon dioxide. Now you say that 12 grams of carbon is utilized. Okay, how much amount of oxygen from the atmosphere? How much? 32 grams. Very good. Okay, so how did you get this 32 grams? Very good. So we know that from the law of conservation of mass, the total mass, okay, the total mass of reactants, okay, is equal to total mass of products. Okay, and here total mass is how much we don't know. So we can write, we know that 12 grams, one is 12 grams, and other one we don't know, that is x grams. That is equal to right side how much we are getting the carbon dioxide? 44 grams. Now x is equal to 44, this bringing this side, so minus 12. 44 minus 12 is 32 grams. Okay, so here carbon is utilizing 32 grams of oxygen. Okay, so is this clear to you? Like this. And see here, one more important thing here is that you also can find like this also. You know that, for example, carbon burn in oxygen. So what we can write is that during the chemical reaction, chemical equation, carbon is C and oxygen is O2. Gives rise to carbon dioxide is CO2. Yes or no? Now what is the atomic mass of the carbon? How much? 12 only. Atomic number is 6, atomic mass is 12. Already we studied, I think, somewhere. Okay, and what is the atomic mass of oxygen? No, oxygen atomic mass is 16 only. One oxygen atom is 16. Like two oxygen atoms are there. So each oxygen atom is 16. So now two oxygens are there. So 2 into 16 is 32. Okay, now you will get here carbon is 12 plus 32, that becomes 44 grams. Is this clear to you? So like this, that is the law of conservation of mass. Okay, very important law, that is law of conservation of mass. Now then we go to the next law, that is law of constant proportions. What that law of constant proportion states? So, law of constant proportion states that very simple, very easy. For example, you see, do you know what is the formula of water? H2. Now, I am taking the water, okay, at Hyderabad. So, I am in Hyderabad, so I will take the water in Hyderabad and I will purify, I will remove all the impurities and everything. I will take only pure water molecule, one water molecule. And if I check that water molecule, so how many hydrogen, how many oxygens are there in that water molecule? 2 hydrogens, 1 oxygen. 2 hydrogen atoms, 1 oxygen atom. That's all, no? Okay. Now, you resided some other place. So, there you take one molecule of water, okay, and check the composition. How is it made up of? So, how is it made? How it will be made up of? 2 hydrogens, 1 oxygen, right? For example, you think some of your uncle is staying in the USA or some, okay, UK, and he is also there taking one, okay, drop of water, pure water, one molecule of water, and checking the composition. What is the composition of water? H2 only. So, the meaning is what? Water is whatever the source it may be, okay, whether you are taking from Hyderabad, whether you are taking from Godavari, you can take from UK or Amazon river, whatever you can take, wherever you can take, whatever the source it may be, the formula of water remains same, that is H2O. Means atomic wise, the water is made up of 2 hydrogens and 1 oxygen. Okay, the ratio of atoms, okay, in a water is H2O, that is fixed, means what? 2:1. And mass wise, if you see, 1:8, that is fixed. So, this is called a constant proportion. So, any substance, you take whatever it may be, okay, any substance, whatever the source it's made from, okay, whatever the source, adi elagana tayaru gani, okay, so whatever the source, it may be prepared, but the composition ratio, okay, the composition ratio of atoms of that molecule remains constant, okay, composition of that molecule, okay, of atoms remains constant. So, if you take water, from wherever you take, water is H2O, the composition remains same, okay. You take carbon dioxide, anywhere you can take the carbon dioxide, it is made up of 1 carbon, 2 oxygen, the ratio is 1:2 carbon and oxygen, okay. So, like that is called constant proportion. So, constant proportion, what it says, very simple, so this law was created by the Proust, okay. Proust was the scientist who proposed this. He said that in a chemical substance, the elements are always present in definite proportions by mass. Always the chemical substances, whatever it may be the source, okay, the elements always present in different proportions of mass. Means, for example, if you take the water, okay, so here you take the water, you know that water formula is H2O. Water formula is H2O, okay, and here water formula is H2O means what? Here ratio of hydrogen is 2:1, okay. Mass wise, if you see, hydrogen atomic mass is 1. Hydrogen atomic mass is 1. Like this, how many hydrogens are there? 2 hydrogens are there. So, mass is okay 2, and oxygen mass is 16. The mass of atomic mass of oxygen is how much? 16. So, if you 2:16, you can cancel it 2 ones and 2 eights. Okay. So, the mass ratio is 1:8. Wherever, whatever the source, okay, you take the water, the ratio of mass of that elements remains constant. So, this is called okay, law of constant proportions or law of definite proportions. Is this clear to you? So, here law of constant in a chemical substance, the elements are always present in definite proportions by mass. For example, see, in a compound such as water, the The ratio of mass of hydrogen to the mass of oxygen is always 1:8. Is here. Whatever the source of water, whether it is a river water, whether it is a rainy water, whether it is a underground water, whether it is a lake water, whatever the water you take, but only water you take. Don't inside the minerals, salts, don't take, only pure water. If you take the pure water, then the mass ratio of hydrogen and oxygen always remains the same, that is 1:8. Okay, the meaning is what? Thus, the meaning is if 9 grams of water is composed, means for example, if we have a 9 grams of water, for example, you think we have taken 9 grams of water. So, that 9 grams of water consists of 1 gram of hydrogen and 8 grams of oxygen are always obtained. Okay, so you can take 8 grams of water. Sorry, 9 grams of water. You take 9 grams of water from anywhere, okay, and you electrolysis. Do you know the electrolysis? Electrolysis of water, I think you might have studied somewhere, lower classes. If you pass the electricity through the water, it decomposes into hydrogen and oxygen. So that is electrolysis. So if you take the 9 grams of water, and if you subject to the electrolysis, this water will breaks into hydrogen and oxygen. Now you collect that hydrogen and oxygen in two different test tubes, and if you measure the mass of these two, then you can find that the mass of the hydrogen is 1 gram and mass of the oxygen is 8 grams. That is fixed. Okay, so that is called definite proportion. That is called what? Definite proportion. Is this clear to you? Right. Now similarly, one more example is also given here. You see now, you take ammonia. Okay, similarly you take the ammonia. Do you know what is the formula of ammonia? Ammonia formula is NH3. What is the formula of ammonia? NH3. NH3 is the formula of ammonia. So ammonia is made up of 1 nitrogen and 3 hydrogens. 1 nitrogen and 3 hydrogens. So see here. Now nitrogen. You see the nitrogen mass is 14. Okay. Nitrogen atomic mass is how much? 14. Remember that. Okay, I will say in this class only. Next, hydrogen, each hydrogen atomic mass is 1. We already studied here. Like this, how many hydrogens are there? 3 hydrogens. So 3 hydrogens mass is 3. Okay. Now the ratio of masses of nitrogen and hydrogen in the ammonia is 14:3. How much it is? So however you prepare the ammonia can be prepared in different ways, different methods. In the lab we can prepare ammonia very easily. So like this, in different ways we can prepare the ammonia, however you prepare. But if you take the ammonia, one molecule of ammonia, and see the mass ratios of nitrogen and hydrogen, that will be always in the 4:3. How much it is? 14:3. 14:3. So here you see. Similarly, ammonia is made up of what? Nitrogen and hydrogen. Okay, nitrogen and hydrogen are always present in the ratio of 14:3. Okay, by mass. Okay, whatever the method or the source from which it is obtained. So however you prepare the ammonia, whatever the source you take, okay, from different sources also you prepare it, but if you calculate the mass ratio, that remains 14:3 only. Is this clear to you? This is called law of constant proportions. This is called law of constant proportions or definite proportions. And ammonia formula is NH3, water formula is H2. Is this clear to you? Chalo, take the screenshot of this one. Are you only taking the screenshots or making note also of this one?
Yes, sir, I am taking note.
So all this, whatever they're taking the screenshots, all you have to write very neatly in your classwork, means in one notebook. Is this clear to you? So here you see now, these are some compounds are given here. For example, calcium oxide. Calcium oxide, if it whatever it may be source, the ratio of by mass of calcium and oxygen 5:2. How do this get 5:2? Your calcium oxide formula is CaO. What is the formula of calcium oxide? CaO. Okay, and calcium atomic mass is 20. What is the calcium atomic mass? 20, and oxygen atomic mass is 16. Okay, now with the 4 table, if you cancel 4 5s, okay, sorry, calcium atomic mass is 40, atomic number is 20, atomic mass is 40. Okay, atomic number is 20, but atomic mass is 40. Okay, if you cancel with the 8 table, so 8 5s, 8 2s. So therefore the ratio of calcium and oxygen in the calcium oxide is 5:2. Is this clear to you? So similarly, magnesium sulphide. Okay, magnesium sulphide. What is the formula of magnesium sulphide? Magnesium sulphide is MgS. What is the formula? Yeah, magnesium atomic mass is 24 AMU. How much it is? 24. Okay, atomic mass units. And sulfur is 32. How much it is? 32. Okay, so now here I am writing magnesium is 24, east sulfur is 32. Okay, now 8 3s, 8 4s. So what will be getting answer? 3:4. Clear? Now next come to the sodium chloride. Sodium chloride is Na, sodium, and chlorine is Cl. So chlorine atomic mass is 23 and chlorine mass is 35.5. Can it get cancelled anywhere? No, I think it cannot be cancelled. So here it is, it will remain same, 23 and 35.5. So here to calculate this ratio, you need to learn the atomic masses of first 20 elements, not more. Atomic mass of first 20 elements you have to learn. I think somewhere during the introduction classes starting I gave, I think so, 1 to 20 elements, atomic numbers and atomic masses. Yes? So that you have to learn, that will be useful here in this chapter. Okay? So take the screenshot of this one also. Okay then. So with this we stop today. So today what have we learned? That once revise after your classes. Okay, we learned what are atom, and then we learned about the law of conservation of mass and law of conservation of law of definite proportions. Okay. Okay then. Bye. Learn perfectly. It's very useful to you. And make the notes also of that, perfect notes. Okay, bye.